Hello everybody, this is Chris Schmidt from Rocket Lasso, and we've got another new version of Cinema 4D. Right away, you're going to notice something different. There is no R, there is no S. It is now just Cinema 4D 2023. They are switching over to a yearly naming scheme that's going to take some getting used to. Now, there are quite a few new features in this version of Cinema, and I'm going to be saving the best for last, which is, of course, going to be simulation stuff. There's a lot to cover, and I've been short on time because this is launching 2 days before the Half-Res conference in Chicago launches, which is an event that I run with some other committee members, and it eats up a lot of time, so everything converging at once. One thing I should mention right here out of the gate is, unfortunately, this version did break all plugins again. So we've already got all of our plugins updated, so feel free to head on over to your Gumroad page, follow your email, you just re-download, it should work again as soon as you reinstall. But there is so much to cover, so let's jump right on into Cinema 4D 2023. The first major feature we're going to be taking a look at inside of Cinema 4D 2023 is the all-new Symmetry System. This one's pretty exciting because it's not just a single tool, it's an entire mode inside of Cinema. So moving into a new scene file, I'll begin by creating a cube. And something I want to point out before we get into the symmetry stuff is we've got this grid here, the grid that's going off into infinity. I don't like the grid typically because it blocks the object here and it gets harder to see the polygon lines if I have those turned on. So typically I turn the grid off, but now there's a new mode if we go under options where we can say, hey, draw the work plane behind the objects. So if I turn that on, you'll see that anything in front of the geometry will just disappear and we only see the grid behind. And I actually really like that a lot. So I'll probably be using the work plane all the time now. Move back into our cube, get a few subdivisions on there, 12 by 12 by 12, something even. Make it editable, go into polygon mode. And what are we going to do here? Well, let's go to our selection tool. And how do we turn on symmetry? Well, there's two different buttons involved in it, and they are up here. We've got this little butterfly icon, which is enable symmetry, and we've got these settings right next to it. If we turn on the butterfly, then it's going to activate symmetry, but we can also move inside these settings, and it's the symmetry hub, and the first checkbox is symmetry, is it turned on or off, and you see if I click that on and off, is doing the exact same thing as the first button, enabling it. Something that is nice to note is you can turn this on and off automatically with a shortcut, Alt-W. So if I hit Alt-W, you can see that will automatically activate, which is why it's great that we have a separate standalone button for it. Moving into the settings, by default, we've got a context of auto, the type is plane, the plane that we're actually on is X, the space is local, and we're restricting to a tolerance of 1. We don't have to worry about any of those settings. The only thing I'll change is show plane, and the instant I turn that on, you'll see a red mirroring plane right there showing us what the result will be, or kind of the halfway point, and that's because it's on the local space of this current object. Now this menu doesn't stay up all the time, you could pin it, but as soon as I click and start doing anything here, that will disappear, and immediately you'll see that my selection in real time is mirroring onto both sides. So I can select anything that I like, hit let's say D for extrude, and I can extrude this in, and it's happening perfectly on both sides. Pretty straightforward, but very easy to activate and begin using. Now, almost every single modeling tool is already compatible with the new symmetry. There's a couple of exceptions, but let's take a look at a couple of the other settings in here. Let's pop it back open, and for fun, let's turn on Y and Z, and now we can see all three of those selected. What's cool about this is you'll instantly see that my selection is mirroring on all three. Meaning, if I hit 9 for my brush selection, I can select all of these corners at the same time. We can do a grow selection, which will grow on all of them at the same time. Do I for inner extrude or inset, and I can pull each of those in at the same time. D for extrude, and they'll all extrude. Very quick, very intuitive to do symmetry that we can activate, turn on, turn off. It's like, okay, I want to do symmetry, Alt-W. I don't want to do symmetry, select a couple things over here, do an extrusion, and then I want to turn back on again, so Alt-W, and now we can begin mirroring again. Something handy to point out right away is as I'm doing these selections, back to 9 for my brush selection, I can do a complex selection, anything that I want to do here. But if I were to turn off symmetry, that selection I made disappears. Only this original one is there. So what if I want to bake that down and maintain it for different purposes? Well, you can find that under the select menu. There is a symmetrize selection. If I select that, it's going to bake the selection down. The shortcut for that is UV, and that will actually bake it down. And now this is our live selection, regardless of our symmetry being on. I can now use that to manipulate it. Next up, I'd like to show using the work plane. So let's delete that cube, make another cube, and back to 12 by 12 by 12, make it editable. Okay. Right now we are mirroring on kind of the world coordinates, or at least this object's coordinates on X, Y, and Z. But if we click on, let's say, this work plane button right here, not something I typically use, but we are now able to manipulate our actual work plane. So if I hit move, you can see I can move not the object, but essentially the world, the work plane where 0 is. Hitting R, I can spin the work plane, let's say a nice clean 45 degrees, because this cube is based on 90-degree angles, meaning we are now pivoting from one corner to the other. So, interestingly, if we go to polygon mode and back into our symmetry settings, this time I'll say I would like to not be based on the local coordinates or the global coordinates, but let's say the work plane's coordinates. And now you can see that our X, Y, and Z are oriented relative to that work plane. But that will give us some interesting mirrored selections now, where if I were to paint over in this corner, it's mirroring across X and across Z and across Y. But yeah, the relative nature makes it so that's a way more complex selection that would have been a lot harder to get naturally. Now, I know we're using very basic objects for this explanation, but you can see how intuitive it is to control this. Now, you could get kind of crazy depending on your object, depending on the degrees. You got to kind of hit that halfway point where that mirroring plane would be. But again, very powerful. This is nice and intuitive. And lastly, if you didn't want to use the work plane, we also have a custom one in which you could, essentially you're moving the work plane, but only in regards to the symmetry hub. And you could pick an object and it would kind of jump over to that. So pretty handy along those lines. I would like to reset my work plane, so I'll turn the work plane tool back on again and zero out its rotation. And let's delete the cube and take a look at a couple of other simple things we can do here. Let's subdivide this plane a whole bunch, 100 by 100, making it editable, moving the polygon mode. So we are currently doing symmetry on X, Y, and Z, but you can do this with lots of different tools. Let's open up the draw tool, Shift C, and I'll type in the word draw. So this is one of the sculpting tools. And I can have this actually be sculpting on all three axes. Very quick, very clean. Mirror this all over the place. Now let's say that you make a mistake and you thought symmetry was on, and kind of zoomed up here, and I'm painting. It's like, okay, cool, that's looking nice. Actually, let me undo that and do it over here. So I'm mirroring all over here, painting. It's like, okay, here's the shape I want to do, get a pattern. Melt it back down again. And it's like, oh, dang, I didn't have symmetry turned on. I wanted it all over the place. Now, we do still have the old symmetry object. I'm not sure. Maybe some changes were made to it. I'm not sure. I haven't looked into it. But we have a new tool under Mesh, under Clone, and that is Symmetrize. And if we pop open the settings that are involved there, you can see I'm going to look at whatever settings are turned on with the hub, which right now is X, Y, and Z. Although, let's turn that off and say, okay, what do I want to mirror on? Well, in this case, I want to mirror from positive to negative on X, from positive to negative on Z, and it will cut midpoints if they need to be cut, and it's going to remove anything that's outside of the current cuts. And just by doing that, if I say, okay, you can now see that that mirrored to the other side. So it's kind of like a one-shot command to mirror along the plane. While we're here, there's one other tool I want to mention, and that is the brush tool. So if we go into the brush tool, which is MC as a shortcut, if I click and drag, I have symmetry turned off right now. You see that we're smearing stuff around. We got a bunch of different modes. We can do things like pull. Well, let's pull these along. If you hold down Shift now, it's going to behave like the sculpting tools, and holding down Shift means it turns into a smooth mode. You see how these are getting smoothed out. So just a little tweak to that modeling tool to make it a little bit smoother. Hitting undo a few times. Let's get back to being symmetrical. This tool does not work just with polygons. We could also set this over to edge mode and paint. Actually, let's reactivate our symmetry. And as I paint here, you see it works with edges. Go to point mode and we can paint with points as well. In addition to that, we can add, let's say, a vertex map. So I'll say I would like a other vertex map. And if you didn't know, you can double click on a vertex map and get a painting tool. And now I can paint a mirrored vertex map however I like with all of the different tools that are applied here, including things like smooth, where I can paint and smooth this, and it's smoothing on all four corners now. In addition, we can do this with a vertex color map as well. So now we can paint with the color white, and I could change this over to green. We can paint with green. And again, all those similar tools, like we can smooth and blur those out between each other. So very nice. We're going to have a bunch more cool stuff to talk about with the Vertex map later. But for now, we can be doing symmetry stuff with splines. I think mostly moving the points around, not so much drawing them. And it also works with things like the subdivision surface weight tag. But for now, it would be nice to talk about what I think is the most powerful and coolest aspect of the symmetry tool, and that is using topology mode. Let's delete this, and just to do a simple example, create a cube, and again, we'll subdivide this. Let's do 10. Actually, let's do an odd number this time, 9 by 9 by 9. Make that editable. And go into symmetry. Let's simplify this a bit, and let's just only, actually, we don't have to worry about that at all, because we're changing this to topology mode. So topology mode is saying, oh, define a selection, either edge or polygon. So let's do that. I'll select polygon mode and make a loop. And let's loop, say, right there. So not in the center of the object, offset. So inside of symmetry, I'll say, hey, define the polygon selection. Those will highlight in red if we have the show planes turned on. And you see a tag is created. It looks like a polygon selection tag, but there's a line through it. So what is this doing? Well, let's go to regular selection mode. If I go to make a selection, it's mirroring across that selection. So things can get really interesting here really quickly, where I can do more complex symmetries in relative locations. So I was able to do this offset from one spot. But now let's do an edge selection, and I would like to select maybe just that 9 for select, and select maybe just those two edges. Now, interestingly, you see it's tried to do a selection over here because it's trying to mirror over this relative polygon selection. So let's temporarily turn off our symmetry mode and select just two edges. In fact, I wonder if you can do just one edge. I don't know. So let's turn back on our symmetry and define an edge selection. You see an edge selection's been made now. And activate symmetry. And let's go back into our selection mode. And you can now see that we are mirroring over that edge selection. And I think it's acting as if the edge selection went all the way around. Because you see, even if I go down here to do, oh, maybe it is relative to that one. We can also do an entire loop selection. Jump over here and define that. But even better than that would be, what if I do a edge selection right there? And instead of moving back in the tool, I can just select the edge selection tag and say update. And now it's changed from one selection to the other, moving into, say, polygon mode. Selection. I can now mirror across this selection, selecting just one side, and it will mirror on the other. So nice and straightforward and very powerful. But now I would like to demonstrate how far you might be able to push that technique by making something a little bit crazier. Now to demonstrate this, I'm going to jump into the asset browser and pull in our old friend, the T-Rex. Stomping around, one of my favorite assets in the browser. In any case, what I would like to do is find a frame where the T-Rex is kind of very asymmetrical, like a big, like kind of the peak of the step here. And then bake this entire thing down. So I'm thinking drop the skin deformer into the body, and then we can say connect and delete, which should bake that down, and everything can be deleted now. So now we got a asymmetrical T-Rex. And then let's make it even worse for ourselves by creating a bend deformer. Rotate that 90 degrees, make it a child, put in a bit of a bend. Setting that to unlimited will make the entire thing get stretched. And then if we say keep length, then now we can see we're curling it around the entire thing. So don't push it so far that it looks deformed. But yeah, just getting a little bit of a curve in there. Again, let's bake this down, connect objects and delete. And now we've just got this model. So now the plan is, let's convert this T-Rex into a dragon, or maybe technically a wyvern. So here's the thought. We are going to be using symmetry. Where should that symmetry happen? And the idea here is we'll use the topological type of symmetry. So we need a line. Because the midpoint is a long edge and not a string of polygons, let's make a loop selection and loop around the entire T-Rex, which I think is great except for this one little part right here. So deselect those two to make sure we don't create any problems. And then set that as the selection inside of the symmetry hub. So yes, symmetry, yes, topological, define the edge selection. Set that, close it, and now we're ready to manipulate this however we like. Activating polygon mode, what are some things we want to do? Well, to begin with, you should be able to see that as I move my mouse around, it's symmetrical on both sides in spite of it being deformed. No matter where I move this, it's selecting both sides properly. I'm not even sure how they're running the math to do this. I'm assuming some sort of like counting the polygons from an edge, but I'm not even sure. In any case, let's get rid of these little T-Rex arms. That's no good for a dragon, so I'll do a loop selection and a fill selection. And you can see both are selected. Hitting delete, they'll both go away. I'd like to close the polygon hole with a grid. So I'll select that spot and do it on both. And you see it has done a perfect job on both sides. Selecting, let's grab these 4 polygons, grow the selection, like these two. MG, I'll be using MG a lot just to iron and smooth the stuff out. Get rid of those a bit. Let's see, the neck is looking a little too distinct right now. So I'll select a few loops right there, maybe even one more. MG, and smooth those out a bit. Maybe even T for scale, shrink the whole thing down. And then MG will blend between those two. Excellent. Okay, so what do we want to do with our dragon here? Well, let's create the wings. Selecting this polygon. D for... Actually, why don't I rotate that in a bit. And then do a D for extrude. And let's pull that one forward. Another extrusion. Another extrusion that will pull out this way a bit. Excellent. That's a good start. Now, maybe a few loops to get these even. So, edge mode, U, B. I know I'm using a lot of shortcuts, but it's always good to memorize the shortcuts. And the example here is just supposed to be about using the symmetry and various modeling tools. Let's put 2 cuts in that one and UB. Do 1 cut here. Just making that, somewhat even. And even all of these, I could grow my selection and MG, smooth those all out so we get a little bit more of a transition there. UL, maybe grow that one a bit and then blend between those two. Excellent. And now let's pull a proper wing out of here. Grab a selection. And once again, you see both sides getting this applied on a very asymmetric object. So, do an inner extrusion, D for extrude, pull those out. Actually, let's pull those out quite a bit. And I'll do a second one, MG, maybe to smooth those out. And then manually pull those out a bit. We got some curvature there if we wanted to. Do a loop. Pull these down. And then, I don't know, let's grab some points and offset every other one randomly. So there we go. You can see I was able to model that all out very quickly on top of this in a very asymmetric pose, and everything worked really well. So an exciting tool to be added into Cinema 4D for sure. Next up inside of Cinema 4D 2023 is something I think people will find very useful, and that is inside the asset browser we have new watch folders. Now, they're pretty straightforward, but pretty powerful. Closing this down, let's open up the asset browser. It looks the way you're used to, but check this out. If I open up a file, in this case some Twitch icons that I use, then you'll see over here something new has appeared. We have a watch folders folder, and inside there is the file name that I just opened up. If I select that, I'm going to see all of the images associated with it. So what's going on here? Well, Cinema 4D's asset browser is intelligently looking for assets associated with this file. If I hit Control or Command D, it's going to pop open our project settings, and inside here you'll see Asset Browser. And if I twirl that down, you're going to see it's connecting automatically to a watch folder, and it's looking for the texture path. So traditionally, Cinema always looked for a texture path, but now we can actually see the different images that are associated with it. So that's the most basic version, where we can actually find these different materials and drag them in quickly and get access to them. But let's go and add some additional ones. In fact, why don't we close this file down? As soon as I close it down, you'll see that will disappear because there's no watch folder anymore. Now, dragging over my Explorer window, you're going to see I have a folder set up here called Rocket Lasso watch folder, I'm going to click and drag that folder directly into the asset browser. And the instant that I do, you're going to see a new watch folder has been created. And inside of there is a Rocket Lasso watch folder. If I twirl that down, you can see I have now added in a link to these HDRs and these models and these textures. Now I just dragged them in, so it hasn't generated the images yet, but if we give it a second, you can see that this has now generated previews of these HDRs. And we've now got previews of each of these models, and these textures have now come in as well. So yeah, what has happened is this is a link to that folder, and it's going to remember this file here. So I can quickly get access to my stuff without having to organize everything within the asset browser. I can now organize things within the File Explorer inside of Windows or on a Mac. And we can do a couple of extra things here. If I open up a copy of this file, I can move over into this delete folder I've got. And I've got an extra 2 scratch materials. So in this case, I would want to go back into this texture folder and say, oh, I've got 2 more scratch files. I'd move those over into here. And as I move them over, you see that blinked. If I go inside here, that has now gotten added in. We've got 2 new materials. If we give it a second, those will render out icons inside of here. And they're ready to be used in Cinema 4D without me having essentially done anything in Cinema. It all happened inside of the Explorer. And yeah, you can now see that those have updated. Now these are all scratch materials. So I could select all of them, open up our details panel, and I can say I would like to add some keywords in here. And I would like to add in the word scratch. And maybe I want to add in, let's say we want to add scratches and create the word scratch. And now that can be saved into a preference file. So now if I search for the word scratch or search for the word scratches, then these materials should show up in spite of them just being linked. Now that information is stored within a database inside of Cinema, wherever your preference folder is. So that information is not stored directly with these materials, but it is now saved and associated with them. And I'm still free to make any changes that I want here. So in theory, if, like right now I've got these different models, if I wanted to navigate into that main folder and maybe move inside and do something more specific, or actually let's move into the HDRs, and I can make a new folder and say I have some indoor HDRs, and honestly I don't know which ones are indoor, but let's say that these 5 are indoor ones. I can drop those inside of the indoor folder, and with those copied over, you can now see a new subfolder's been made, and I can now navigate and see these direct ones inside the HDR folder or the ones inside the indoor folder. And those will each render out their icons. So yeah, a watch folder, a way of linking to an external file. Another thing that we have inside of the asset browser now is we can say view, and we can say show contents of subcategories. So you'll see right now, if I click on the Rocket Lasso folder, all I get is 3 folders. But if I say, hey, show me the contents, then we will see these individual groupings of files all automatically expanded. So I didn't have to navigate to each folder and find them. I could just see all of the assets. Something I should mention that's also been added is this auto panel, and I think it might default to auto. Now, this actually did exist in the previous version of Cinema, except it was actually this button right here, which was auto mode, but it was kind of hidden away. I didn't know what the icon meant, but now we have the word auto here, which is great. And what that does is, depending on the context of what I am doing inside of Cinema, it's going to populate this list with relevant things. So let's hide the data, and what would I like to do? Well, let's say I'm doing material stuff. If I select the material manager, then this is now updated, and this is showing essentially materials inside of Cinema. If I select the object manager, it's going to be showing objects. So whatever part of Cinema you're in is what this will be populated with. So just another little handy thing there. Also to point out, we've got a couple new icons down here at the bottom. Here's that cascade button. I can turn this on and off, and that will cascade down through all of the folders so you can see all the contents, just a shortcut for that. We also have the ability to group by certain things, and also here's the sort by as a quick menu, so we could say reverse the order or not reverse the order and flip them around per category. So yeah, quick access to those different things. And one last tiny thing, if I search for the word coffee, there are 8 new coffee tables, all designed with some Redshift materials ready to go. If you want to navigate to the folder, you can always right click on one and say reveal in asset browser. And here are the 8 new coffee tables. So just a little bonus there. Let's close that all up. And then next up is an experimental one for me. It is an improved Go Z plugin. So I have not used the ZBrush in a very, very, very long time, many years. So I'm going to open up ZBrush right now. I just downloaded and installed the newest version. Just opened up ZBrush. Let me drag it over and maximize. So here is ZBrush. I would like to install the new Go Z plugin. So inside of Cinema, I'll say extension Go ZBrush and say Go Z install. Installation complete. Okay. So assuming that worked, let's head on over into ZBrush. I literally have no idea what I'm doing here. This might be useful for an upcoming file. So I'll double click on this lovely looking statue. Moving back into Cinema, let's open up a new file and say extensions, Go ZBrush, Go Z importer, and see if anything happens. I don't see anything. Let's head over to ZBrush and maybe we have to do some sort of export button first. Looking around for the word and Go Z. Click that button. I'll say I'm gonna ignore that for now. Just hit continue. And let's go back over to Cinema. Hey, look at that. So straight out of ZBrush into Cinema. I mean, that might have already existed for a while. I'm not sure. I imagine this has got quite the polygon count. Yep, significant for sure. And I believe some of the new stuff is involved in the assign poly groups. So if you're a ZBrush user, I'm sure that means something to you, and we should be able to assign the poly groups now because that's being highlighted as something new. But we might be able to use the statue for some of the upcoming things. So let's move on to those. And those are changes to Redshift. Now, Redshift operates on a different schedule than Cinema 4D does. Of course, Cinema has changed to this yearly number, but several updates have been coming out in the year, which seems to be a new trend that Maxon is doing. But it means that they're not quite synced up. Things come out throughout the year when it comes to Redshift. And I'm not going to cover all of those details. Depending on the way things go in the future, I might be able to make a separate video. But I think back in July, there's a couple of additions that were made. And there's something involving like volumetrics and the way that light hits them. For the older things, I was only going to cover one thing, and that was going to be the new random walk. So moving back into the statue that we just brought over, how about we shift everything over into Redshift, create a Redshift area light, scoot it up in the air, I'll move it way over here, rotate it. I think I'd like this to be mostly backlit because we're going to be focusing on subsurface scattering. Scale it down. That's probably going to work. And let's dim it a bit, just on my guess here. Zoom up. Now, something's going to be a little bit tricky here because my machine, especially while I'm recording, doesn't like running Redshift. I'm going to be upgrading my machine shortly, but let's see what we can do here. So let's talk about the random walk. Popping open a new material. Let's delete that default one that it came with and create a new Redshift material standard. So new standard material. This icon won't refresh. I turned it off from doing that. And you can see over here in the attributes menu. And again, something to mention is if you single click a Redshift material, it'll open up in the attribute manager. But if you double click, it will open the node editor. So just a difference between those two things. So moving on in, why don't we open up our render to render view. And stop that and activate our IPR. And it's going to require some time for it to refresh. Like I said, it's just a thing that my machine's doing. So there we go. You can see it's a bit grainy and it's going to stay that way as long as we're looking at it. I'll brighten this light up a bit. And let's move directly into the material. Scrolling down, we can take a look at our subsurface. Here it is. So you'll see the mode has changed to random walk as a default. But it is very, very simple to use. You can grab the weight of it and pull it up. This will be overriding your color channel as you do it. So you might not want to bring it up all the way, but I'll bring that up quite a bit. And what's a nice color? I guess let's go with a orangey color for our base here. And without doing anything else, that should create some subsurface scattering as simple as giving it some weight, and you don't even have to give it a color. Now, letting this refresh, it'll take a bit. I should apply the material, that will help. And let that refresh. As it refreshes here, you can see it's going to be very grainy on my machine. What I'm going to do is set up a render where we look at this in the older ray traced diffusion. And I'll set this to do a bucket render, and then we'll A/B test. Okay, it does not want to render this last bucket. Again, whatever trouble this computer has with it. Let's send that to the picture viewer. And then give that a pause. And now let's switch this to the random walk, changing nothing else, and render that again. We'll see how that one looks. Okay, took a bit, but this is done rendering, and I am going to do a couple quick A/B tests just with these essentially defaults set on there. And you can see that we are getting a lot more detail in these small areas. There's a lot more definition. You see how like the nose here is just kind of all red. It's all flat and red. We're getting quite a bit of color blowout here as well. When I switch over, we get so many more smooth gradients of color, and I don't know, just the overall shapes. Like this is just a big block of red, and here you can see how it gets brighter and darker. So yeah, overall I like the look of the random walk a lot more. There's definitely a lot more to talk about, but we have more things to cover. So you should definitely take a look at setting your radius here, moving these sliders around. You can choose how deep any color will penetrate through the model. But that's all we're going to do to cover the random walk. And as I said, that came out a while ago inside of Redshift. But now let's move into a different feature that has come out alongside this version of Cinema. That is the ability to apply decals, or that's sort of the way it's being referred to, but it's actually just the ability to layer materials on top of each other. So let's move this up to the front. Change this to a default standard material. And like I said, that's not going to refresh. I have it turned off. We'll make a second one, and I'll name this one Rocket. And inside of that material, let's pull in a texture. And in the texture, let's add that rocket from earlier. So let's move into here. We'll grab just the simple kind of Rocket Lasso decal and feed that into, actually we don't even need it in the color channel. Let's get a splitter and extract from that PNG just the alpha, putting that out to the opacity. And as part of the standard material, I'll say, hey, I would like it to be emissive. We'll make it very bright, lots of color coming off of that. And we'll just aim for a nice orangey color. Cool. So that's all I'm going to do there. Apply this material on top of it, and let's set that to be flat. Change this to a texture mode, and T for scale. Scale this down. And let's view this from one side. Scale it down until it fits on this pedestal. And we'll put one there, duplicate that, and drag this over. If you've ever dealt with all of the difficulties of layering two materials in Redshift, let's take a look at what we have here. Render to render region. Start this up. We should probably select both of these and turn the tiling off. And as soon as I do, we can now see that we've got two rockets projected directly onto the model. Decals are now that easy. We can do simple material stacking just like we've been able to do in vanilla Cinema forever. So a wonderful addition. You can imagine putting graffiti, layering grass and dirt on top of each other, adding grime layers, and separate scratch layers, so many different things, and you can just layer it as separate materials now. So that is wonderful. Let's close these out and close everything. Next up is something that I hope there will be at least some people who will be as excited as I am to have this feature, and that is new procedural vertex maps. And I'm actually understating it here because it's not just vertex maps, it's selection tags with point selections and color vertex maps and polygon selection tags, all of those. Now, I'm going to demo this via a file that I created during a live stream, and I thought it'd be kind of applicable here. Almost everything I'm going to be doing is going to be things we've been able to do with vertex maps in the past, although I think it's kind of a fun technique. The difference here is we can do it procedurally. Because of fields, a vertex map doesn't need to be on an object that's been made editable anymore. We can make it procedurally by feeding fields through it. So let's step through this step by step. There's a couple of caveats. It's my understanding that this might be something that got snuck in at the last second. So it's not fully implemented yet, but it's too exciting not to talk about. One more caveat on top of it is, much like Xpresso, when you need it, you need it, but it's hard to think of demos ahead of time of what would show it off. So this is just one example of where a vertex map is incredibly powerful. And during, like, especially any work I do or live streams, all the time, vertex maps solve problems, but they're always very specific. But in any case, let's build this from scratch. Right now I've got a plane, it's got some subdivisions, and I've got 2 cubes with vibrate tags on it. If I hit play, they're just drifting around. The idea that we want to make here is I want to make some animated kind of cartoony ripples that are traveling along with these shapes. So let's do that. Now, the wonderful thing here is I can add a vertex map via other tags, vertex map, and not make it editable. Now, I can't paint on it. If I go to point mode, I can't paint on this vertex map because it has not been made editable, so it can't store that individual point data. But the vertex map by default has fields turned on now. You'll also see that it's operating at generators 5 priority, which is relatively late, something that we should keep in mind. But in any case, if I go into a field, I can now add in, say, a spherical field and scale that up, and that is now on a procedural object, something we have not made editable yet. So that's where this gets exciting. What I would like to do, we don't need a spherical field, but I would like to feed the geometry of these 2 cubes in, and I don't want to do them separately, so I'll create a connect object, feed both cubes into that. I don't need to weld. And in the vertex map, drag the connect object in, view it as a point object, and you can see these 2 little points show up. I'd like to view that geometry not as points, but let's do it as a surface. And I can increase this radius and have it fall off from the objects. So now we get a nice big fall off, fading from both of them. And any other objects we drop in there, we could add more cubes or different objects or a boat or whatever we want into that connect. It'll automatically update. Excellent. So we got that fall off. This is our base vertex map. I think I might like to add a decay on there. If I hit play, let's make this a little more obvious. If I hit play right now, you can see these traveling around. If I create a lovely decay, I can start getting a bit of a trail fading out behind them. It's going to be a subtle effect given the setup I'm doing, but I think it's pretty neat to do that. So let's increase that radius again. And as I do, you're going to see it's harder to see that, but it is there. All right. Now, something I like doing with vertex maps is layering them up. So instead of doing a whole bunch of stuff in this one, we can say, okay, this vertex map is done, and I'll make a duplicate of it holding down control. And in the second one, I'll delete all these inputs. The first thing to do is rename it. I'll just say vertex map 2. You can be more descriptive, which would probably be a good idea. But in this field, I'll just drag in the original one. So now I've brought this field over. Now, like I said, this was just implemented. I think there's a couple of refresh issues. I'll just say that. I'm still really excited where this is not updating immediately. So we'd have to keyframe something. But in this case, the problem's automatically solved because I'm feeding in a random field. And the random field's got a noise, and I'll have that be animated. And as that is animated, we're going to see this vertex map automatically update. I'll set this to overlay. And you can see how that's animating around. Let's see, do I want the noise to be quicker? Yeah, we'll go a little bit quicker there. And I'm going to keep on increasing the scale of this noise until we kind of, I don't want to feel the individual dots of the noise. I just want to feel some variation on the ripples we've gotten. Like right around here, you can see, okay, that feels like some good variation without seeing the noise. So now if I let go, you can see we get these ripples here. Let's slow the noise down. I'm going a little bit quick there. So they're nice and drifting and modifying that just a little bit. So there we go. We got some randomness on our fall off. Now let's add on a formula. Now don't be intimidated by formula, especially the way we're going to be using it, which is we've got this formula typed in and it's creating these nice waves via a sine wave, but we don't have to worry about changing any of this equation. All we have to do is change these settings here. So twirl down your variables and we can change our frequency and make the loop happen more often. So you see we get kind of some nice distinct ripples here. And then we've got the time, which can affect the speed. So let's slow that way down. And we can set exactly how many ripples and how fast they're moving outward. So that's pretty much working exactly the way I want it to. That's looking really good. Something you'll notice is because our fall off doesn't go super far out, we've kind of got this alternating yellow, red on the outside. We don't want that. So why don't we make another vertex map, immediately rename it. If you don't rename it, then the vertex maps can get confused as which thing it's supposed to be referencing. So always rename them. In this vertex map, let's delete everything again. I'll drag the second vertex weight in. Again, you see it doesn't refresh right away. we could keyframe something, like we could keyframe this opacity, and that would actually force it to update. Again, though, I'm going to add in a random field and set that to, I'll probably set it to overlay. And inside the field, I'll again add in some animation speed and crank that scale up again. I want to, maybe I'll set that to straight up multiply. So yeah, some parts will be brighter and some will be dimmer. Increase that again so I don't see the individual noise. Just adding some more variation. And what would I like to do? Well, I think I'll drag in the very first vertex map. And now you can see we've got this original one. And I'm doing that because I'm going to set that new copy of the original vertex map 1 to multiply, which will make this entire thing fade out, because the original vertex map has this nice fade. And now you can see a little bit of why I like to layer these up. But in any case, you can now see that we've got these ripples traveling around the object, trailing slightly behind them, and the ripples moving outward in a somewhat random way, but very nice and controllable. So having done all that, what I would like to do is make another copy of this plane so we don't get a feedback loop. And we can delete everything off of there. And this will actually get our water material. This one doesn't need it. Hiding the original object, we're just going to reference it. So in this case, how about deforming this with a plane effector? Drop this as a child. I would like this to be a deformer, so I'll set that to point. And the parameter should not be pushing up on Y, but instead on Z. Now we should see everything pop up. Everything's going up. And typically I would rename this dot deform, just so we know it's being treated as a deformer. But I don't want it applying everywhere. So let's move into our fields and drag in this vertex map. So we've got this vertex map. You can see that it's looking for the nearest point. We could say literally the same index. And every time I click, it's going to update, but it's not updating right away. So that is a refresh issue, which I have high hopes for in the future. But I'm going to get around that by telling it to refresh, just by keyframing whatever. So in this case, I'll keyframe this opacity, go to the end, and just go down like 1%. So visually, I won't see a difference. But now this number will be updating every single frame, which means our animation is actually updating every single frame. So you can see I've translated these 3 vertex maps into deformation pushing upward. So it looks pretty cool. Let's create a smoothing deformer. I'll put that last, and we'll pull back on the stiffness and only do a couple of iterations here. So like here's only one iteration, smoothing that out a bit, but we can increase it. So that's looking good. But here's where, first of all, we didn't have to make anything editable. But in this particular case, why I like this is we could be like, okay, well, we demoed it with a low poly version, but maybe we want to increase it. Maybe we want there to be more ripples. So if I go to that second vertex map, I could say, okay, we'll add more ripples in. And as I increase this, actually, I'll turn off the smoothing so you can see it. You can see that they've gotten really tiny and sharp. Like we don't have enough resolution for them. My smoothing is pretty much obliterating the ripples. But now I can grab both of these planes and crank up the segment count. And now we have way more polygons and everything just updated to it automatically. I could drag this entire setup onto completely different objects like a sphere or different pieces of geometry. Change any of these polygons. I could grab both of these and T for scale them up, update it that way, make any changes that I like. This is deforming upward a little bit too far for me now. So let's pull back on that, not quite as high. And yeah, make some nice, more subtle ripples. But you see how quickly I can refresh that. So yeah, some basic, well, this wasn't basic, but this is one application of being able to do some procedural vertex maps. And things get pretty exciting where you think about applications that we could push this with color vertex maps. And like I said, during my live streams, I'm probably going to be using this over and over again. And we'll even see a little bit more of it when we talk about the new simulation stuff. But while we're here, keep in mind that we could apply other things like our color vertex map. So applying a color vertex map on here, this would also work. Now we're not seeing the original one. So let's just visually bring back the original one. And with this color vertex map, I can do something like create a linear field. And I can see I can colorize the linear field, scale that, and modify the color however I like. Go into our color remap, change that to a gradient, and load in a crazy cinema gradient. Let's grab a rainbow color. And the entire thing get applied procedurally. This is actually colorizing the individual points and all sorts of overlays on top of that type of thing. And as I mentioned, this can be on, let me just open up a new file. This can be kind of any setup that we like. In this new file, I'll create a text object, make the font a little bit thicker, and set that to the middle. And something I've been doing is let's subdivide this a little bit more by changing this to subdivided. I don't want it based on angle, but instead every 5 units. You can see we get a nice even kind of point count going around, meaning feeding this into a lovely remesher will give us a nice even polygon count kind of all around the thing. And what do I like to do now? Well, I'll feed this into a connect object. So that's kind of viewing the final geometry. And now I want to create a selection tag. So in this case, I'll say, hey, make a cube, make it editable, polygon mode, and give me a store selection. And I'll steal that tag over. Maybe somewhere here in the menus. I'm just not sure where it lives. But anyway, inside of that selection tag, I'll say use fields. Don't worry about the freeze, but instead we'll just make a linear field. So there's a linear field traveling across the entire thing, but we can't see it. That should be selecting about half the polygons, but we can't tell. So opening up the material manager, I'll double click, make a new material, drag that over and say, hey, material, be limited to this tag. So as soon as I refresh it, I can now move this linear field and say where the active selection is. Now this isn't limited to materials. Anything that could see a polygon selection actively should work. Like we could feed capsules through here to be seeing exactly where this linear field is telling the selection to be. So it does open up a lot of really cool possibilities. And keep in mind that this will also work on the point selection tag and the edge selection tag. So let's close all these files down. Here's a little one about a small tweak to the way Xpresso tags work. Opening up this simplified file, I've got 3 different text objects, a spline and 2 mode texts. Selecting this, you can see that this is outputting information, that little icon. We've had that for a while. The arrow on the right means outputting. This one also outputting. This one says it's inputting information, meaning this is being controlled. If I try to type something else in here, it's going to get overridden because something's happening. But it's like, well, what is controlling what? And I've got 3 different Xpresso tags. It's like, well, one of those tags is controlling this. I don't know which one. Well, now if you hold down Alt as I click on this output, it's going to pop open a little dialog now. And you could say, open up the Xpresso editor, or you can also select the Xpresso tags involved with this parameter. So any Xpresso tag that uses this parameter would be selected. So I can click on that and you'll see that that tag has now gotten highlighted. So that we know that that's being controlled through this tag. Selecting it again, let's again hit Alt and click on it. We can also say jump to, and you can see it says a text spline. So this is somehow outputting to a text spline. If I select that, you see it's actually jumped over to the spline and highlighted the parameter that it is controlling. Now this actually goes both ways. If I select this one and hold down Alt, you'll see it actually has 2 different ones. We can jump to text 1 or text 2. So if I select that one, you'll see it jump over here, meaning, hey, this parameter is driving it somehow. The reason that happened is if we go inside of the tag, this is taking text 1 and text 2, combining them with an ampersand, and then outputting that. So it's just the relationship between them. So this might not seem, it's very specific, but just to show you, it ends up being incredibly useful for me. I'm currently planning the conference Half-Res in Chicago, and we do these cube races every year, where I've got these kind of advanced Xpresso cubes that have all these behaviors, kind of like a video game programming where they go and they hop around. I've been trying to make changes, and this saved me so much time where check out like how many Xpresso tags I've got just controlling a single cube. So here's this cube, and I can open this up and you can see there's some Xpresso, there's more Xpresso, there's more Xpresso, here's the combat system, and then controlling all of them, we've got even more Xpresso and more and more and more, and there's like way more like Xpresso throughout this entire system. So it's like, okay, there's a lot going on, but now I can be like, okay, like I need to decouple this light, and if I delete it, it's going to break some Xpresso tag. But now I can see I've got that input. Holding down Alt as I select this, I can say select the Xpresso tag. This one's not driving another parameter, so this one can only be involved in a tag, and I can select that, and now I see that of all these tags, it's actually this one that's being controlled. And inside of here, there it is. I am now controlling the color of the light via this setup, and I was able to find that very quickly thanks to that. So a very simple thing, but when you're in a scenario like this, man, did that save me a lot of time. Close all of these. Next, we have OpenColorIO and ACES inside of Cinema 4D. Now, there have been some people who've been requesting this for a while, and here it is inside of vanilla Cinema 4D. Now, a couple caveats for myself. I don't do a lot of compositing, like at all. And especially when it comes to something like the ACES workflow, I am not very familiar with it at all. So I'm going to try and present the most basic version of this to people who don't know what the system does. But if you are interested in it or want some more advanced information, I recommend checking out some videos by I Go by Zach, and Chad Ashley has an excellent series over on Grayscale Gorilla Plus if you're a member over there. So let's open up a scene file. I've made this very exaggerated so it becomes obvious what some of the things are doing here. I've got a robot character with some very saturated materials, and I am lighting them up with a very bright lights, which are also very saturated. So opening up my Redshift render view, let's scale that up a bit and hit go and check out this IPR, and we should see that we've got the robot and it is very saturated and very blown out. You see how kind of flat all of these colors start looking, especially this red. Like everything here is like just solid red across the board. Like I said, I am way going overboard here with the saturation, but this is just straight materials, straight lights on top of it. So the most basic version of OCIO can be found if you go to your project settings. So Command or Control D, and inside of the project settings, you can go to color management. And here you'll find basic, which is the classic linear workflow. And then we've got our OpenColorIO. First, I'll send this to the picture viewer so that we can A/B test them. And now I'm going to switch my color management over to OpenColorIO. So you're going to see these all blink, all the materials change, and my render view has also updated. But because I had these simple Redshift materials already set up, I can just hit Convert to OCIO and say, yep, default. Again, I'm doing the basic version, so I'll say yes, default. And that's going to convert all of the lights and the materials to work in the ACES workflow. What is going on here? Well, the most basic idea is different devices, like your 3D software, different photos you take, different videos, they're all using different color profiles, and they're managing like the gamma differently, and everything is just all over the place. The idea of this system is you take all these different inputs, interpret them, and then everything's kind of interpreted the exact same way. So any modifications you make now work perfectly across the board, and then you output all of them at the end into whatever format you want. So I'm not going to go any deeper than that really, but now that I have converted these over, we've got this render, let's send that over to the picture viewer, and we still got these incredibly saturated colors, but let's take a look at the difference. As I click from one to the other, you're going to see that just how blown out this is. Like we've got almost a solid color red with just a little bit of darkness on top of it going all the way across the board. When I click onto the new one, you're going to see that we actually have some more kind of gradients. We have some fall offs. Look at the detail here on the fingers. If I click on this one, everything is washed away. If I click over, even as saturated as I made everything, we suddenly can get a little more detail popping out. Let's look at the color blues that we've got over here on the leg. As I click over there, very, very flat. Jump over here, the blues are able to come back through. So essentially there's a lot of like saturation bloom happening where you can see everything just gets washed out. Look at the dark area here under the shoulder. I click over, you can see that the shadows have pulled back out again. If we look at the shoulder here, just how sharp everything is, and click on this, and now we get a nice fall off of even these incredibly saturated colors. Now, this is filtering straight through into Redshift, so automatically that's working. If you're familiar with the previous workflow inside of Redshift, this will actually override it. So inside of Redshift, if I was inside of our basic mode and we go to, I think, globals, yeah, you can see we've got this color management, and you could have manually added in the different ACES setups. I can now switch over to this, and you'll see that that disappears and it's getting overridden by kind of this overall project setting. In addition to that, now that we are in the OCIO, I can go into one of my materials and actually don't double click, single click. And if I click on this color picker, you can see that the color picker is going to show different modes in which we can pick things. So by default, a good idea is if you want to set a particular color, you can click on display, and now what your eye is seeing is what is going to get applied overall. So again, the most basic possible version of this. I'm planning on learning more about it And there are some really great resources online to check it out. But that is integrated, and anybody who's been looking forward to working more closely with ACES, it is now there inside of Cinema. Close this all down, and let's jump into the best thing in Cinema 4D 2023. And of course, I had to save the best for last, and that is huge simulation updates. You probably know that I'm pretty obsessed with the simulation stuff inside of Cinema 4D, and this is a huge update for what we've already had. So let's jump in and just start stepping through some of the features, and we are just going to be scratching the surface of some of the possibilities. To begin with, let's open up the scene file. I've got a head from the asset browser, and there's a collider tag on it. And then I've got this sphere surrounding it. This is actually a question I was getting a bunch during some live streams. Right-clicking on the sphere, I'll add a simulation cloth tag. And there's only one thing that we need to do on this one, and that is change our target length, an all-new target length. Now, target length kind of happens instantaneously, so we have to keyframe it to transition it into a new size. So let's keyframe at the time of 0 and go 90 frames in. And let's shrink this down to, I don't know, 34%. So we've got this head underneath. We are now going to scale down the target length of this object. Let's hit play and see what we get. And we're going to get a pretty perfect shrink wrap immediately around the object. As simple as that. As I mentioned, you do have to keyframe it. If you don't, let me show you. Let's turn off that. If we let it instantaneously happen, like just jump to 34%, you're going to see it's going to pop pretty bad. It still surrounded this head pretty well, but can kind of escape and start passing through itself. So good idea to do a transition here. Now, it's important to note that what this is actually doing is every one of these points essentially has a connection between each other. And this is telling the length between those connections to get longer or get shorter. So let's do the opposite. Let's pop it up to be something larger, and we might see some intersection. Yeah, you can see if it expands too quickly, it kind of passed through itself. So if we rewind and instead transition into that size, we can jump up and say, let's go up to 200%. And because it's happening over a series of frames, you can see it has time to grow. Couple details I'd like to put on top of this. If we move into the balloon tab, which has now been moved into its own tab because there's a lot more settings now inside of the cloth tag. If we turn on balloon, that's going to be attempting to pressurize our object. So it's a balloon and it wants to maintain its shape with that exact amount of pressure. Well, the target length doesn't see that balloon setting. So let me show you. If we kill off these keyframes and at the time of 0, it'll be 100, and 90 frames in, we'll have shrunk it down again. Keyframe that. Watch as this starts to go down because it's trying to maintain pressure. If I hit play, you're going to see that it can't shrink. Like, it gets a little bit rounder. You can see it gets some nice clean curvature around there, but it can't shrink any further because the pressure's saying, like, no, you're inflated. I can't go any further. But let's do the opposite, and it's trying to maintain its current pressure. Delete that, keyframe, and keyframe again, and jumping to 90. Let's say at this point it wants to inflate, so it's going to get larger. So what happens now is it's trying to maintain the same amount of pressure, but suddenly the object is getting bigger. So you can see that it gets larger, but that air, there wasn't enough air to fill the entire thing. So you'd actually have to inflate it as well. Kind of important to note that there's not a one-to-one on that because the scale is the length, which is kind of two-dimensional, but the pressure is three-dimensional. It's cubed. So in spite of going less than double the length, we probably have to go, I don't know, 5 or 6 to get to the proper inflation. Yeah, probably up to 6 to do something kind of like cubing the number. So the numbers don't pair up super cleanly, but if you don't turn on balloon, then it's not worried about pressure and it can just scale properly. So keep that in mind, but that's very fun. That's just the super duper basics of what we can do with that though. So let's move into the next scene file, and we'll be using the T-Rex a couple of times here, but this is pretty fun. What I've got this time is under surface. We've got the target length. We set that to whatever we want. In this case, I'll jump it to 33%, so a third the size. And then underneath the target length, let's even do this from scratch. Let's add a brand new vertex map, and the vertex map will be controlled via this linear field. So let's turn on fields, drag in this linear field, and you'll see that the linear field is saying, hey, there's no power anywhere. We have to move the linear field on it for that to take any effect. So let's say that the target length is multiplied by that vertex map. So let's apply the vertex map, which is already there. It's already in the name, so you'd have to delete the name. But if you drag it in, then the name is added. So You can set a minimum target length, which is nice. We can say, hey, don't get smaller than a particular size, but this should be set up properly. We're aiming for 33%. I have gravity turned off. If we hit play, you'll see the T-Rex is just kind of hovering there. But if I grab the linear field and I start to move it, the tail is going to shrink as I pass through it. And if we go all the way through, you can see we can shrink the T-Rex down to 1/3 the size. And look at all this like goofy stuff we can do by changing the scale around. So you can have a lot of fun with that right out of the box, just inflating and deflating it to any length. I mean, I suppose that could also be going larger. So let's jump that up and let's see what happens here. I haven't done this. So as we pass this through, let's give ourselves more time. As we go through, you see the tail gets longer and the T-Rex gets bigger and then the head is left behind and then we can pull it back in again. So you can make brand new dinosaurs by changing the scale of this. So even right there, just this length parameter, very fun, and there'd be so many different things we could play around with and change. I mean, you could be using an animated noise through there, as you saw with this T-Rex. Oh my God, so many possibilities. Like, it's insane. Let's move into the next parameter, which is probably the most fun. So very basic scene here. I've got a plane object and a couple of spheres. Let's make the plane a collider, and both of these spheres can become cloth. Let's get rid of the bendiness for now. And the parameter we're going to play with this time is going to be stickiness. So stickiness is a parameter. We've never had anything like it before inside of Cinema. So let's say that this plane is going to become sticky, and I'm not sure what a good number is. So let's start out with like 55, and we'll also set these to a sticky of 55. And actually, you know what I should have done? Let's put 0 stickiness there. Let's see what it looks like out of the gate. So you can see we get these two spheres just kind of bouncing a little bit. They're very low poly, so they won't bend too much if we have the bend down to 0. So now let's add in some stickiness. And when I hit play, you're going to see that they got stuck together and they're sticking to the ground and then slowly roll off the edge. Let's bring some of that bendiness back in so they can squish a bit and hit play. And now you'll see them squish into each other and get stuck both to each other and the surface. Let's make these a bit inflated, try and maintain some pressure, but we'll also make them a bit stretchy, and let's make them super squishy. So now they're just blobbing down and sticking to each other. Like, it's such a fun and intuitive parameter. Sometimes you have to go to some decently high numbers, but let's lower these numbers a bit and see if we can get them to slide around a little bit. Yeah, you can see how this is, look how it kind of crawls off of it. Like, that's so cool. Let's add a few extra frames here. And yeah, that's the basic setup with stickiness. Now, of course, you can feed in a vertex map here. But let's do something like we've been talking about. You can do parametric vertex maps. So let's do something with that, but not essentially directly involved in feeding it into the simulation stuff. But instead, let's blob these together as a liquid to start out with. So how should we do that? Well, we can do it real simple. Let's make a volume builder. We'll feed both of those inside. And inside here, let's build that into a volume mesher. Not changing anything else. If I hit play, these will both fall down, squish into each other, and you'll see they'll blob into each other. But let's make it look a little bit nicer by adding some smoothing on it. So let's add just a bit of smoothing. We don't have to go too far, just enough for those to blend in a bit. And then hit play. Let's see what we get. The smooth always makes it goes a bit slower. But yeah, now those will blob into each other, but they're sticking, and this will still roll off of it. We could make this lower poly if we wanted to run a bit quicker, but this isn't even what I wanted to show. Those are blobbing together, so you can maybe make a liquid-esque thing. But now, let's do something even fancier. What I would like to do is control the color of this. So we can do that with a other tags, and that will be a vertex color. Now, I'm going to want this tag to be refreshing. So I think that we're going to need to put, well, let's do it wrong before we do it right. On this vertex mesher, I'm not sure if it'll refresh right away. We might need to put in the connect, but let's just experiment with it. I'll select the tag, and it's already using fields. So I could say, look at sphere 1, and what will sphere 1 do? Well, it's going to, right now it's viewing the points, but we could increase the radius of those points. You can see how the colors are applied, and they're also falling off onto the other object. That could work. We also turn on surface, and you see they'll do a little bit nicer job of filling in all the colors. And then we'll drag the other sphere on, and this one will also say to see colors. It actually it'll also be surface. Now, it did come in as a different color, but let's make it a bit more different. So we'll make that one green. Actually, let's make it yellow. So we got yellow and a blue. So let's go ahead and say, okay, that looks cool. I want to hit play, and let's hit play and see what happens. And you'll see what's actually happening is the colors aren't following the model. And that's because the simulation is happening after the vertex map was checking it. But we can work around that by feeding this color, or I'm sorry, feeding this sphere into a connect, and it does not need to weld. And let's feed this other sphere into a connect. And essentially that's baking down whatever it's seeing from the simulation. So now we do have to go back into our vertex map. And like I said, we do it wrong before we do it right. So let's replace that one with a connect, and let's replace this one with the other connect. So that should have updated to those different models now, baking them down. And now when I hit play, it is following the color. Oops, let me keep that selected. Now, as I hit play, the vertex map is actually bleeding and blending the colors between the two as this blobs around. And man, that is really cool and really powerful. Like, this is an exciting addition we can get. We can layer things up a little bit more. If I wanted, I could duplicate that vertex map, delete the input of the first one, rename the tag as I was talking about earlier, and feed in the first tag. So if I feed that in and I set that to average, then I can blur these colors together even more. I could do it only a little, or I could push that a lot. So now as these melt into each other, we'll see those colors blend even more. Nice and smooth transition between the two. And we could add as many different objects into that as we want. And the entire setup is procedural. We didn't make anything editable. And that's because the vertex maps now have the power to work on top of a procedural object. So very excited about that. Next up, if you've got some stickiness, then you've got to do a meatball rolling down a plane. So here's a couple of splines, and the splines also can get stickiness applied. And I've got this ball ready to roll down there. So not even setting up, because it's pretty much the exact same settings. You can see if I hit play, these will stick to the plane, and now the ball will stick to the ropes and pull them and tangle them up as they go. So stickiness also works with ropes, which interact directly with the cloth as well. So pretty exciting there. There's more to talk about with sticky, but before we get there, let's talk about another new feature, and that is adding in what they're calling Softbody, but really it's just adding poles to it. Now, this is another thing that we've never had before in a simulation system inside of Cinema. Now, what do I got here? I've got a text object. Let's step through here. And it is subdivided a bunch via the adaptive, which then gets baked down as a connect. I feed into a remesh, which is making the poly count very even all the way around, very even size polygons. And I'll connect that to bake it down as a single clean object with a proper fong. Excellent. So, it's just a model. And we've got the ground here just as a collider. So on this text object, let's right click and add a simulation cloth, and just leaving it all defaults. If we rewind and hit play, and let me make sure that I set this to CPU. My computer goes faster with that one. If I hit play, you'll see this will fall, and they kind of squish and they fall over, and they're not maintaining their shape very well. Now, the best we can do in simulations previously is set our bendiness down to 0, and you'll see that these will actually get a lot stiffer. But, they're still falling. They're still very bendy. And it's only because they're very low poly that that's working. If these were higher polygon counts, let's increase the poly count by changing our mesh density up to, 1,000%, which is going to add a lot more subdivisions on there. So with more subdivisions, if I hit play, we're going to see all of them fall. 0 bendiness, but we'll see that these are very squishy because, the weight of everything is still pulling it down. In addition to that, there's no relationship between any of these numbers. But in any case, let's drop this back down to something reasonable and go inside the cloth tag, where we now have a Softbody tab, which we can enable. And the instant I enable it, we're going to see a whole bunch of lines crisscrossing inside of the mesh. So what's going on here? Well, it is creating a series of poles from each point, which essentially shoot out a ray, shoot out a laser, and whatever it collides with, it's like, okay, I'm connected to you. Now, to see this, if I play right now, we won't see too much, but if I set the softness down to 0 and then hit play, there is now more internal structure. And we have a lot of controls that we can add on top of this. But in order to make this even more blatant, let's immediately jump to another setting we could do, which is the shoot side and hit side. So right now, they're starting from the inside and hitting the inside. So it's on back and back. But I'm going to say, when you're shooting out these lasers, set it to both. So, and then when it collides, it can hit both. And now you'll see that we're actually getting some connections in between the numbers. But let's increase our count. I can say max poles per point. And right now, each point is shooting out 1 pole. But we could say go up to 2 or go up to 3. And then we also have a minimum length, a maximum length, and we've also got a spread. So right now they're randomly rotating out up to 45 degrees, but let's push that even further, and you're going to see that I can get a little bit more webbing in between, more connections inside of any number here, but also between the numbers. So having done that, hit play, and we'll now see that they're still nice and bouncy, but they're connected to each other. There's a relationship between each of them. Now that's with a softness of 0. We could reset that back down to 0, which means those poles themselves become kind of squishy. And you can see that those were able to kind of do a really nice solid bounce, but they're still connected to each other. They're still attempting to achieve this shape. So the poles add internal structure. So this is incredibly powerful. Now there's a whole bunch of settings in here, like you can tear these poles if things stretch too far or squish too much, they can break. We can show these always, or we can turn it off so we don't see those connections. This is only when we actually have the tag selected that we'll see them. Something else you'll notice is as we turn these different modes on, the icon is going to change. So if I turn off this soft body and we turn on balloon, there's a balloon icon. If I turn off the balloon and I turn on soft body, you see we get this jellyfish icon because it's now a soft body and we got all these interconnections between them. So yeah, just a little more information about what might be going on inside of a tag. Now we could increase the pole count. We could add more softness or 0 softness. We could add even, you can see right there, even as I changed it, that how these are stiffer and they relate to each other more. Like it's just very intuitive to use this control. So I am super digging it. There's a lot to explore here. We have different controls. Like each of these can be twirled down and we can feed in vertex maps into all of these different controls. They could have different softnesses in different spots. So like the 2 could get squishy and then the other ones would be more stiff, or we could transition from one to the other. The possibilities are going to be absolutely crazy. We also, there's even a target length here. This will probably be a little bit crazy. It's going to jump to it. But if I hit play, you can see it's going to try and increase the size of them and the distance between them. So, and again, you'd probably want to animate between those. But so many different controls and so powerful to add these soft bodies and add structure to this cloth. So now that we've talked about adding poles to things, let's jump into the next file where we can combine both some stickiness and those poles. So let's see if we can build this by adding in all the different simulation tags. So what do we got? Well, I've got some text here. You'll see that it is very cleanly subdivided. And then I've got this roller. And the idea here is it's supposed to be like a rubber roller, and it's going to roll over this text and it's going to stick to it. So I got some keyframes. If I hit play, you see that this pole right here is just moving straight ahead. It's not rotating. It's just moving. It moves down a little bit and it moves across. Okay, so what tags would we want to add on here? Well, this ground is already a collider, so that's already set up. But let's make it so that this cylinder will be a collider as well. So let's say, yes, you are a collider, but we'll give it, let's say 0 friction for now and probably 0 bounce. So this can actually collide. The rubber can collide with it. And then let's grab the roller. Right-clicking, we can add a simulation cloth tag to it. And right out of the gate, it should be there. It should be squishy. Let's see what happens. If I hit play, you can see that, okay, we have a roller on there and it is moving with it. And it does seem to be able to turn, but it's losing all of its shape. And it's not sticking to the ground very well. So let's add a bunch more friction onto it. So hopefully when this touches the ground, you see it's being forced to roll a little bit more. And we want to maintain its shape and probably not bend, so I'll turn off bendiness. And let's add on some ballooning, and that's going to try and maintain its current volume. But if I hit play on this, you'll see, yeah, it's maintaining the volume, but it's very bouncy and squishy. Now that might work where we kind of get this squishy thing, but I want that to have a little more stiffness to it. So I will add a soft body, turn that on, pole, and now you can see it's shooting all of these poles out and making a bunch of connections. Let's get rid of pretty much all of our spread variation though, and now it's just shooting the pole directly from a point and it's colliding with the more inner point. That should add a bunch of structure. Let's get rid of this softness that we talked about in the previous section and hit play. And now as this rolls, you can see that the shape is being maintained really well. And as it's squished down into the ground, it's rolling forward. If I go to a side view, you can see that this bottom is getting squished a little bit because it can't quite fit in between the roller and the ground. So that's all working very nicely. What do we want to control now? Well, let's go and add the simulation onto this remesh. And the remesh is just making this nice, even subdivided text. So right-clicking on that, I'll add a simulation cloth, and that should just be cloth now. It should be fine. We probably want it to be pretty bendy because we want to bend with the roller. And we can add some friction on there. So I'll jump that up to 5. And let's not add any stickiness. We'll just hit play and see what happens now. You see it falls to the ground slightly. And now this roller is rolling on top of it. And okay, that's fine. Like it seems to be not exploding or anything. So now let's go back to our roller and add on some stickiness. I'll start with 5. It's probably going to be too low. And let's go to the remesh and set that to a stickiness of 5. And then hit play. And let's see what we get now. We'll go behind to see if it's doing anything. And actually, that's working shockingly well just with a 5 on there. Look at these numbers sticking to it like pretty much perfectly. Now, I think they've got some weight to them. You can see how it's like forcing that roller to fall a little bit behind, but that's fine. I don't have a problem with that. We could lower the mass. So here is the mass. I could say, actually, you're very light. We'll set that to like 0.1. I'm not sure what that will do, but let's hit play. I guess the roller does stay behind a little bit, but you can see how these are sticking. They're very light now and they can get stuck to it. So with that sticking so well, why don't we just add on some smoothing? So after all that's happened, I'm smoothing it out a bit. And then I'll bake that down, put it into a cloth to add a little bit of thickness. And then the second connect is just to clean up the fong. So now we're rolling over this flat text. And it is sticking to the outside of the roller and just rolling across pretty much perfectly. So yeah, stickiness combined with the poles on here. Now because of this hierarchy I did, it is going to visually lag 1 frame behind. When I pause, you'll see it jumps on there, but it will render out correctly. So yeah, that's all working great. Let's delete that roller and rewind. And then just to have a little bit of fun, I've got a different roller already set up here. So the exact same setup, except I made it this crazy squishy sphere. So hitting play, as this rolls over it, it's not a nice flat cylinder, but so you can actually see the text will roll around and kind of catch the outer part, take on the shape of this as it rolls over. So, yep, there you go. Some extra stickiness on there. Like, man, so much fun. It's going to be fun thinking of demos and doing live streams, answering questions about this, because we're going to be able to do so many cool new things that we hadn't thought about before. Again, scratching the surface of a couple of these tools, but there is even more to talk about when it comes to this Softbody. So let's open up a brand new file, and let's pull in that T-Rex again. So I'll search for the word Rex, grab the best walk cycle inside of Cinema with our T-Rex here, and let's go inside of the model. And I think I only want the body here, so we'll delete the teeth and eyes. So there we go. We have an animated T-Rex stomping around. That's looking good. Let's clean up our viewport a bit. Okay, so stomping around T-Rex. Now, the soft bodies, or everything involving cloth up to this point, we couldn't do anything with animation. Like we have all those amazing MoGraph tools like follow position and follow rotation in the old bullet simulation system, but not inside of the new cloth. But now we do with this new tab. Right-clicking on the object, simulation, cloth. Now, if I were to hit play right now, actually I should make sure I go to CPU. If I were to hit play right now, we're going to see that the T-Rex just loses all the animation and it just is a piece of cloth now. It just falls out of the scene. But we've got a brand new tab, and it is called Mix Animation. There are 3 main settings. We've got pins, force, and follow shape. They're similar, but they all do very distinctly different things. Now, the first one is with pins. And essentially what that is doing is it is taking the current state of the cloth, and it's creating like a spring connection between where it currently is and where the current cloth is and where the mesh has moved to. So let's start out with that one. If I say use pins and hit play, suddenly our T-Rex doesn't fall out of the scene anymore. He's just there. Now, if you go all the way up to 100%, then it just snaps. It's just forcing it there. So yeah, technically it's a simulation, but it doesn't really mean anything in this context. Where things get interesting is applying this to only, well, first of all, we can lower the strength down, and you're going to see as I go lower that it is reacting to the animation, but in kind of a weird squishy way. It's kind of, it's got weaker springs attaching to different spots. But where pins gets really useful is saying, you know what, I kind of only want part of my simulation to like be stretchy. Everything else, I just want to be baked down exactly like the animation. So for this, why don't we do a similar setup where I can make the vertex map and again, use a field, and I'll even pull back in a linear field. So now our linear field can face along Z, and now some of it's being affected, some of it isn't. I'll feed this into the map for the pins, and we can, actually we'll just crank that up all the way, and let's hit play and see what we get. you'll see that the entire back half of the T-Rex is now completely clothed. It's just flopping out of the way. But everything on the other side of our linear field is 100% stuck doing the original animation. So if I were to move this further in, you can see that we can actually transition in and have the entire thing fall away, or we can transition back out and it's going to snap back to its original position. So you probably want to be a little more gentle with it as you pass this through. But if I start feeding this through a little bit, we can start getting this tail to react in the simulation a little bit more. Now we have additional settings inside of here. We can say, actually, what is the map strength? Right now, everything on that side of the tail is at 0%. We actually pull this back. Let's find a nice number here, where you can see it's getting extra bounce because it's getting 81%. Even at 0, it's still getting 81%. So that's what you should use pins for, is like part of it should be simulated, but some of it shouldn't be. And let's have a little more fun with this. Drop that down to 0, and I'll spin the linear field. Oop, not 0, 100. We'll spin this around, and just moving this around, you could get some crazy things where like the entire head now is Softbody squishing away. But we can pull that back in and say, actually, you should have a little bit of structure. And you see it flopping around there. Now, I'm kind of doing some silly examples, but yeah, right here actually is a pretty good balance where you can see we get a little bit more like flopping simulation going. But if we applied this to someplace a little bit more specific, let's see if we can do it in our, let's get rid of that linear field and switch this to a spherical field. And where would I like to put that? Well, we'll just move it down here near his little T-Rex arms, scale this up quite a bit, delete that linear field. Scale that up quite a bit. I might be overdoing it there, but let's feed that vertex map is still fed in here. So now if I hit play, then hopefully we can see. Yeah, look at his arms now. Look at his poor little T-Rex arms. They're just kind of like just flopping around. So yeah, really, really great. Like very straightforward if you think of it. That pins is for making part of your animation be a simulation. Now, I want to show you a limitation here. If I were to make a sphere and move this up in the air, and let's make that a cloth as well. If I hit play, you're gonna see that that's gonna fall, and I think it's just gonna like essentially pass right through. It's barely reacting to the T-Rex at all. And that's because those pins are like, I 100% have to be here, so they can't react back the other way. So let's try a different setup instead. I'll turn that sphere off a little bit. And in this one, let's turn off pins. That's not doing anything anymore. And let's use force instead. Now, if we're using a force on it, in your head, it's a little bit hard to distinguish between these things. But instead of a spring on there tugging it to a particular location, it is now almost like imagine a little wind on each point, blowing it in the direction of the current position of where the model is animated to. So even with a strength of 1, if I hit play, you're going to see that the T-Rex is moving and it's not falling away, but you see that the animation is a little bit janky, like it doesn't quite know how to move because these points, the strength isn't strong enough for the points to quickly get to where they need to be, so it's not fully taking advantage of the animation. Now we could crank up the strength here. Now it's up at 5, and now you can see it's matching the animation a lot better. We could go up even higher, and as it gets higher, you can see it's trying to match the animation even more, like even more tightly it's trying to match. But let's go back to something semi-reasonable. And well, now you can see this made of cloth. It's kind of squishy, but this one would be, if we turn on that sphere and it falls, you can see that this one will actually collide with it. It is able to react to it. So potentially we could pin parts of it, and then we could also use force on parts of it, and those combine in some very interesting ways. This one would work well if you got maybe a bunch of letters that are in a cloner and they're supposed to be moving around in a particular spot, and now the force can softly blow it in the direction that it should be. So we'll leave force at that. And then the last one is actually follow shape. And follow shape, I don't know how well it's going to work on our T-Rex here. Let me turn it on and see what we get. So if I turn it on, you can see that, first of all, gravity's taking over. Let's turn gravity off, Control D, and we'll say no gravity. Hit play, and now we'll see he's staying in one spot, but he's kind of like flopping all over the place. Let's move into our surface and get rid of all the bendiness. Now, what is actually going on in this one? Before, what was actually, it's going to look a little bit funky right here, but what was happening before, that's funny. Yeah, the T-Rex might not be the best example for this one. So what is happening is before a point, it's really, really technical. as we use pins or force, both of them, it's like the T-Rex started out in a particular position, and the soft body's like, well, this is the position I'm supposed to be at. Like, I'm trying not to bend. I don't want to deform more than I have to. So the original shape is maintained, but any given point is kind of being yanked to say like, oh, but I want you to move to this one. I know your original shape is in this pose, but I want you to move to this new position. Follow shape is different, where follow shape is actually saying, hey, update the model. Like, your base shape isn't what it looked like at the beginning. Your base shape is whatever the animation is changed to. So it's constantly updating that base shape. So this will actually work pretty well in conjunction with the other ones, where the base shape is moving, so it can try and catch up to that, and then the wind is pushing it more quickly into that position. So a fundamental change, that's the fundamental difference between follow shape and the other two. It's technical, but there are specific times to use it. And as time goes on, I'm sure I'm going to find more and more uses for how to mix these things up with each other. But let's move on. I mean, essentially, we've now talked about pretty much all the new settings, but I had 2 more quick demos I want to do just to show you some of the power of what we're going to be able to do with this. So let's move into this file and start combining some of the things that we've learned. I'll delete the tag. This is already set up for the final animation. You'll see I've got some low poly hands here, and here's a piece of cloth with a decent number of polygons. And I've got this selection tag where everything's selected except for the very back of the hand. Also, if I select both of these hands, you'll see I've got a couple keyframes, a very, very rigid animation where the hand moves down, passes right through this cloth, right through the table, moves back up again, and then moves away from each other. Okay, so that's what we got. So let's say what we actually want to do is have this hand touch the table and not just go crashing through it. So let's start applying some of the things that we've learned. Right-clicking on the hand, I'll add a simulation cloth tag. And if we rewind, hit play, of course, it's just going to fall away. It doesn't care about any of the stuff. It's very squishy, falling right away, not doing too much. A little friction seems to be pulling that cloth a little bit. So what should we do? Well, I think I want this hand to follow those keyframes. So we got a couple different ways we could do that. Let's move into the mix animation. And we know that if we want just part of a simulation to get soft body or the cloth applied, then we can use pins, which is a very kind of rigid way of saying lock it in here. So let's activate that. And now it's like saying 100% I have to follow. So it's still going to pass right through. Does us no good, although the cloth is sort of acknowledging it. So I don't want it to apply everywhere. I only want to apply it in some places. So let's drag that vertex map in called pin. And now if I rewind and hit play, let's see what we get. Well, now it's moving down very quickly, and it is following. You see the back of the hand has to go wherever I told it to. So the rest of it is chasing behind. Now something we're seeing is that, yes, it's moving with it, but the hand doesn't have enough structure. So if we want to give the hand structure, well, we've learned about the poles inside of Softbody. So let's activate that. And I don't want it to be very soft. I want these to be decently rigid. Essentially, a finger shouldn't be able to squish down. So let's get rid of that softness. And then I might want some more poles here. So let's add like 3 poles per finger. We could add more variation on the direction that they're going so they could strike other points and get like more cross bracing. And some of these are like aiming really far across. You can see a couple of these are stretching all the way across the hand. So I'll limit the length, the max length, down to something a little bit shorter. In fact, we go down and slowly go up until we've got the right length connections for what we want. So with all of that done, let's say don't show those anymore because I don't want to see them all the time. So now the back of the hand has to go where we told it, and the hand should have more structure. So let's hit play and see what we get. Well, now, actually, yeah, the hand does have way more structure. Now, it did slam into the table, and that's getting yanked up, and I think that sort of passed through the model a little bit. So maybe we'll turn that bit of cloth off for now. But now you can see, boom, slams in. The fingers are getting a little bit left behind, but that's working all right. Like, especially at the top, look at the natural movement with the terrible keyframes I've got. Once this hand goes up, look how the fingers kind of lag behind, and we get this beautiful overlap of the fingers up at the top. Like, oh, so straightforward. But right now in the beginning, you see this is still kind of escaping the hand a little bit, and it does slam the fingers in really hard. So maybe in this case, we don't want to use the pins. The pins are very kind of a brute force thing. So instead of that, let's turn off pins and use some force. So essentially, they'll just be like a wind force pulling a particular part. And that particular part will be that same pinned vertex map. And if I play, it's probably going to be a little bit weak right now. but you can see that the hand, it does stop there, but let's give it a little bit more power. Actually, let's see, as it goes up, you see it can't follow. Mostly gravity took over. So let's add more strength. And now suddenly you see at 6, it yanked up and it went to where the hand used to be. So now look, as this hand goes down, it's moving a lot more gently. It's not slamming it into the ground so much. So if we can find a nice kind of middle ground here, I'm not sure what a good number is, but let's try maybe 4. Now you can see this hand goes down, and look, it's touching the table just a little bit more gently. So yeah, just different ways of combining this. We could probably even use a little bit of both of them. So let's like lower the strength of this influence, and I don't know what's a good amount. Let's get some forced amount and then some force. And yeah, the finger's getting left behind. Mostly I'm interested in the way it touches the table. And that's pretty good. That hits the ground a little bit hard, but then it pulls up and it's wiggling nicely. So yeah, I'm pretty pleased with that. So I think I can just copy that tag over to the other hand. And it's already being told to look at pins. So it's going to look at its own tag called pin. Actually, this one's called, yeah, they're both called pin. So that should be looking at those tags properly. So hopefully just by copying it over, now we've got 2 different hands with 2 different motions. And now you can see this hand very daintily touches the table. And then they both travel up and we get some nice overlap of those fingers. And then they get pulled apart. So yeah, very pleased with that. Now the settings here can get a little bit specific, so we'll have to see how it goes. But let's activate our cloth and let these go down. And now we'll see that it's actually colliding here with the top of it. And then as we pull away, maybe they'll, yeah, that's actually fine. The cloth reacted to it. But let's start making these sticky. Let's grab, I think the cloth here is already sticky. Yeah, so yeah, there's already a little bit of stickiness on that bit of cloth. But now we're going to probably make these hands very sticky. So we'll start with 5. When it comes to any of these settings, 5 is a good amount where it's like you should see an effect. So if I hit play, we'll see these go down and it collides with the cloth. And then with any luck, okay, it definitely reacted, but it didn't stay very stuck. Oh, something I'm going to do that I might have forgotten about is we've got tearing. Oh, I guess that's still off. Okay, good. Let's go 10 times as strong. So I'm going to make it 55. And let's see what this does with 10 times the stickiness. So now it collides there. Okay, good. And starts pulling up. And look at that. It's definitely more stuck. It didn't stay with it entirely. So let's add another 5 to that. And now as it strikes, it's even more sticky. And let's see what we get. It's like, okay, that's now enough where this is starting to stick to the fingers and actually get pulled up pretty well. Now this is actually sticking everywhere on the hand. So something that we could do is say, actually, stickiness, I want you only to be limited, and I've already got a vertex map here, of the fingertips. So I can say, okay, only the fingertips will be sticky. And we can do that on both of these. So now with the fingertips being sticky, let's see if we can drop that down. There, only a couple of fingers touch. So one of them missed. Let's see, that pulls it up, and just the fingertips held it. So looking good, but let's crank up the strength even higher, up to 5,000 now. So now, as it collides with the cloth, this is really strong. There's a lot of forces trying to pull this cloth along. So now, as it pulls up, it does successfully pull this up into the air. Excellent. And now, as the hands pull apart, oh, I guess the tearing was turned on. That's fine. I have tearing turned on the cloth, and the fingers were able to tear the cloth as it pulls them apart. Now, you can massage these settings a bunch. I'll revert this to my original file, revert to saved. And my settings will probably be slightly different. You'll see here that, yeah, it's really strong stickiness. But on the mix animation, I'm just using a force of 11, and that was enough to get what I think is this very nice gentle touching. Every finger touches the cloth. And then as it pulls them gingerly up, the hands react very nicely. And then they stick the cloth, and then they pull apart, and we get a nice tear between them. So there we go, combining a couple of the different things that we've learned, and you can see how exciting some of the stuff is going to get. And I know there's a couple of people out there who like doing animations with like floating disembodied hands, and look at some of the cool stuff that you're going to be able to do now. Now I've got one last file here. It was a little particular. I had to do a lot of like trial and error to get the settings just right. So we're not going to rebuild this one, but let's just check it out. There are some rigging files inside of the asset browser. So this hand is already there for other people to go and load. And you can see it's nice and low poly, and it's almost the exact same setup. And let me show you if I delete the cloth. Here are some terrible keyframes I have on here. There's a couple of controls on the hand. I don't know where the controls are. Here they are. User data, where I can close like the fist and the fingers and everything. So here's what the animation looks like. The animation is keyframed, statically goes down, and then makes a little gripping motion, and then it moves back up in the air. Like, completely terrible, not elegant, not smoothed out, like there's no clean curves on it, animation whatsoever. So, hitting undo, I'll bring my simulation cloth tag back again, and now you see that I've got a tag that is got the fingertips to be sticky, and I've got this pinned tag saying this entire hand can be very cloth-like, and the arm is going to be very rigid, and that is all pinned. And here we've got, yep, a bunch of soft body poles interconnecting, adding some structure to the hand here. And I think that's pretty much it. We've got a bunch of stickiness just like before, so, and a bunch of friction. So check this out. I hit play, now it's going to fall down, but now it doesn't pass through the table, and now it's going to grip the cloth and then pick it up off the table. Now, it's a little bit jittery right now, but just playing around with this, it's like, oh my goodness, look at the possibilities here. A demo I didn't get a chance to put together, but I've been thinking about is imagine like a character's face, and you make the cheek soft body, and then the hand soft body, and then you have the hand like rub the cheek and have it kind of squish and stretch around. Like, there's so many possibilities here, combining these things, adding structure, telling it to follow the keyframed animation, telling things to stick to each other. Combine that with these parametric vertex maps. Like, it gets absolutely crazy. It's so much fun, and I can't wait to continue exploring this. And I absolutely love that Maxon has been continuing to develop this simulation system. So, yep, we'll definitely be seeing more of this from me in the future. It's just too much fun not to demo. Like, oh man, look at that. So, let's leave this nice animation looping as I say my goodbyes. Thank you so much, everybody, for watching this video and for supporting Rocket Lasso. If you'd like to support Rocket Lasso, the best way to do it would be to pick up one of our plugins. So not only do you get cool new tools and new functionality, but it's the best way of supporting us. So there's also a Patreon, and you can do things like subscribe to the channel, etc., all those things that people say. But in any case, that's going to wrap this one up. Thank you for watching, and I'll see you in the future in another tutorial or live stream. Bye-bye, everybody.